Hi guys, welcome to this little video about target marketing analytics. This little video is made to show how in practice you can actually perform targeting marketing using statistical analysis, using Minitab, using Excel, and k-means clustering and things like that. We use targeting analytics for many different things in marketing. First of all, we use it when we perform different types of tasks that relates to identifying customers we need to work with. So targeting analytics deals with things like product development. So if we're looking for customers to target a product to, so who should we target? It can be used for targeting communication to specific target segments or similar things. So that's what we use targeting analytics for. When we do it using statistical analysis, this is typically the methodology we use to do targeting. So the first thing we need to understand is the purpose of the targeting. So what is the business needs? What is the strategic needs that we have in front of us for why targeting is necessary? This could be pretty simple. Let's say we want to make an effective communication campaign in front of the next elections. And so the purpose of our targeting will be, for instance, to get some psychological profiles for different target groups in the market in order to tailor-make specific advertising messages for them. That's what Cambridge Analytica did last election in the US in 2016 when they influenced the elections in the US. Step number 2 is then the choice of what dimensions to use to segment on, and that normally depends on the type of data we have. The example I'm going to run you through today relates to a study of flavor in terms of chocolate preferences. So in this case, we are looking, and today we're looking at an example where we use chocolate flavor preferences to do the clustering by. Step number 3 is the typical first step in the actual analytics. And this is where we clean up the data, where we identify how dirty the data is and decide how to clean it up. Step number 4, this is where we determine what is the optimal number of clusters. And for that, we use normally elbow analysis and k-means clustering. So once we have decided the optimal number of segments, we then identify the cluster segment membership, so who is in what cluster. And then based on that information, we profile each of the segments or the clusters in order to understand who they are so we can better work with them. So basically that is how we do targeting analytics. In order to make it easy for you guys, I made a little list of the video content so you can move back and forth in terms of what you're interested in. So we start with this little introduction and an introduction to the 6 steps of analytical targeting as we've been through. The next thing I will do is show you the data and introduce the example that we're using. We will then go on to, or I will go on to showing you how to clean up the data and organize the data for the analytics. Then I will introduce briefly the elbow analysis. What is an elbow analysis? Then I will show you how to run the k-means clustering analysis with the statistical software Minitab in order to get the numbers for the elbow analysis. We will then move on to taking out the information from the Minitab results and completing the elbow analysis using Excel in order to determine the optimal amount of clusters. And then we will go on to doing the k-means clustering analysis for the optimal number of clusters and transfer that into Excel in order to be able to identify who belongs to what cluster. And then we will do the cluster profiling. I'll show you how you do the Excel analysis, how you create the data that can be used for profiling, and then how to create the graphs based on the profiling data. And that's it. That's what this video was all about. So let's say we are working with a product development effort where we are looking at targeting different types of chocolate consumers. And the purpose of the targeting is to understand what type of taste clusters there are in a segment in order to figure out if we have covered the different taste clusters with good products, or if there might be an opportunity for developing a new type of chocolate for different taste clusters in a market. So the purpose in this case will be to inform the development of potentially new chocolate products based on the different taste preferences that there are in a chocolate market. The data we have available for clustering is shown in this sheet, and let me maximize it so you can see it. This is a study, a flavor study of chocolate preferences, chocolate taste preferences. You can see on the left side in column A, we have the respondents that's been asked different opinions about chocolate tastes. And then you can see the question that the respondent has been asked here on a scale from 1 to 5, to what extent do you like these chocolate flavors or ingredients? And then you can see here in all the rows here that there are questions about specific types of flavor or ingredients in chocolates. And on the right side, you can see a few demographic information about the different respondents in terms of age, gender, and their location. So that's what we have of data. In this case, the choice of dimension is pretty obvious because we are working with taste-based clustering, so taste-based segmentation, and we have a lot of different taste answers here. So we will use this question with these dimensions in order to do the targeting. The next step is then the data cleanup and organization. So the first thing we want to do is to figure out if and to what extent we have dirty data. And when you have a sheet like this, normally you'll have to find a place to do your analysis. In this case, let's do it at the end. So let's look at how we do the cleanup. So first of all, we have to decide what type of dirty data testing do we want to do. Normally, the first thing we do is to figure out missing data. So let's do missing data. The second thing we want to find out is if there's errors in the data. And let's look at the type of data we have in order to determine what errors we are checking for. In this case, we have a scale from 1 to 5. So we will expect all the data to be within the scale of 1 to 5. So that's what we're going to use for the missing data. So let's go down again to the bottom to complete our data analysis in terms of the data cleanup. So the missing data. So what we're going to do here is to do a simple count. So you can follow along in the top here. You can see what I'm putting in. So let's do a count with a formula. We want to count the ones that are blank. So you have a function here called count blank. Then we just mark the cells out. Then we have a count of the missing data. In terms of errors, we are looking perhaps for two different things. So errors would be if we have data that is less than 1, and we have an error where we have data that is higher than 5. And let's put in a formula that can identify these two errors. So the first error would be count if, and then we are looking at the range. Let's input the range again. That one. We have the range, and then we have the criteria. And here you have to remember how to put it up. Otherwise, you can use the formula function. In this case, we are using apostrophes, and we are counting if we have something that is less than 1. Close it up, and then we have that one, right? So you can see here, that's the formula for that. And then we'll do the same thing for the error that's on more than 5. So we will use this one here. I'll just copy paste this one in and put 5 in here. All right. So we just want to double check that this is correct. This should be larger than 5. All right, here we go. So now we have the 3 formulas. Count how many blanks, count how many are under 1, count how many that's over 5, and then we will make a total error, total dirty, and then we'll do a count of how many do we have, observations. And then we'll do a dirty percentage. All right, so total dirty will be just a sum of what we found. Number of observations, that's just counting the data set we have. So this is just a very simple count. So it's the things that are not empty. Just this one. And I'm just marking them out again. And then we take, in terms of the expected count, I forgot to put in that one. Expected count would be if everything was complete, which is basically all the ones we have here. And in this case, if this is correct, so if this A is the correct number in terms of respondents, we can use that one, or we can look at inputting a separate column where we do a standard formula, and then we can see how many data sets we have. And this is a manual method. You can see we have 663, and that would be the expected count. That's for all respondents. In this case, you can actually see there's something going on with the respondent identification. So we do also have issues with that. In that case, we will move this one out, and we will treat this as raw data as well. So we can probably extend this one here. See if we can backward extend it. There we go. So we have the same formulas here, so we can actually check if we have missing data. All right, but what's most important would be these ones. In a later video, I'll go into more details with how you actually look at the respondents' errors, but for this one, what's interesting here is the missing data in terms of the data set. So let's take this one out for now. Right, so we'll do this. We know the expected count is 663, and this one we have 661 observations, and in this case we have 2 missing and no erroneous data. And then we'll do a dirty percentage to see how many of the dirty data we have of the total expected number. And in that way, we take the total dirty and divide that by the expected count, and we turn that into a percentage. So now we can have a percentage, and then normally we'll take a few commas so we can see that in the granular detail. So once you have these ready, you can basically extend that. And let's do the data we're going to analyze. Here you then will have an overview of the dirty data in order to see what type of dirty data you have. And of course, what you need to do is do a cleanup, one type or another, In this case, let's take a look at the percentages. The rule of thumb says that if you are not using detailed subgroupings and detailed comments, a standard strategy, if you have less than 1% dirty data, would just be to omit them. And in this case, if we're using averages, and which we're going to do, we can input the central tendency or the average. So in this case, let's look through this list here, the dirty data. We have one at 0.9%. We have 0.9 here again. So, and we have 1, so that's probably the level. And in this case, in order to make it easy, let's say that what we need to do here in terms of cleanup, because we're going to look at different types of averages that the strategy we select in order to clean it up is to input the central tendency. So that's why we add central tendency. In this case, let's do the median, because it's the categorical data from 1 to 5. So we'll do the median. We will produce the median for all of them. Median. There you go. We have the median now, and then we extend the median to all the different rows. All right, so now we've done a short little analysis of the dirty data. We've chosen a strategy for how to fill out the missing data, which is basically the problem we have. And then let's try to make a clean data sheet out of this. There are other types of issues. If you look at the error data here, you can see that we do have other issues. So we have data that is outside the range. In this case here, we have 2 data sets or 2 data points that are higher than 5, which it should not be. So this one will also need a decision in terms of what we're going to do with those data. So in order to do that analysis, let me just show you how you can do that. So I'll do the sorting, and we are sorting. Let's see what row it was. We are looking for these 2 data points where errors is over 5. So we'll sort it on G, and G is caramel. So we do simple data sort. We choose G, caramel, do OK, and then we can go to the bottom, and then for manual, we see that we actually have 2 observations that needs to be corrected one way or another. We'll have to decide what this answer should be. It should obviously either be taken out, or we should correct it to something else. All right, so that's how you actually look for and figure out the secondary strategy for certain types of data. Missing is one thing, and then the second thing will be to clean it up for the erroneous data. So let's clean up the data. So in this case, let me show you how I typically clean a sheet up like this. So first of all, I will copy all the headers, the data I'm cleaning up, and in this case, I'll just show you for the flavor. So we'll just do this part of it. So you see I copy them over next to it. And so in order to clean this one up for the missing data, what I do is I input what I need here. And in this case, so the one you see on the right will be the cleanup data sheet, and this is the dirty data sheet. So here, the first thing I want is, of course, the respondent number. In this case, it's one over here. For the second one here, I'll have to put in a formula that puts in the clean data. So in this case, we are looking at putting a formula that cleans up the data. Now, this is normally a if formula. So we'll put in an if. The thinking here is if this has something in it. So let's say if C4 is more than 0, then what is the value if true? Well, we'll put in this one. And then what is the value if it's false? Then we're going to put in what we decided, which was the median, right? So we'll put in this one. So that's the formula for this one, right? Now, the only thing we have to do now is then copy it into all the sheets, all the data sheets here, all the data cells. But before we can do that, we just want to make sure that the formula is correct. We only want data for this one from the row of medians. So that's why we put in a $sign. So we fix that when we copy it. Otherwise, the rest seems fine. So in order to clean this one up, we first of all just copy in the respondent number for now. Let's do this one. Let's see if I do that. Okay, I'll do it the manual way for now. We don't have that many rows of data, so there you go. So now we have all of them. And then this one here. I'll drag this down as well. All right, so now we have input, the median, and all the empty cells. So that was step number one. Now, step number two was then to correct the ones where we had erroneous data. In this case, we have these two here, and we wanted to make sure that this also gets corrected. So what can we do here? Well, we first have to decide what do we think what strategy we need to follow. So can we assume that 6s should have been 5s, or that these ones for some other reason were erroneous? In this case, what I decide is that they probably put in too high a number. So if it was manual input, so they could be 5s. So in this case, I could either say change them to 5, I can change them to the median, or I can omit them. Now, if I omit them, I'll have to put in the median. So in this case, in order to make it simple, I would just say, all right, let's take them out. These are missing. And now you can see the erroneous data went down. What I normally do here is that I change these to text so I can still see them. So I can format a cell. I can do it as text. But you also have to change the formula then. So for in this case, let's just take them out just for ease. We have 2 here as well. And in order to clean it up, you will also have to do it for that one. So in this one, you will have to make sure that that you also do the cleanup for this one. So that's the method. But for now, yeah, let's do that at the same time here. So we'll do a sorting for that. And remember, this one has a formula, so you actually don't need to include it, but you need to include these ones. Here we go. And then we do the sort. We'll just have to figure out again what cells we're looking for, and we're looking for J. J is hazelnut, so we will sort on hazelnut. Here we go. Now we sort on hazelnut. Let's see what error we have here. We have something that's less than 1, so we have to go to the top for hazelnut. We have 2 that's 0. Let's take them out as well. And we'll put in the median. So now we'll take them out. And then again, we're still looking at Arrhenius data. Do the Arrhenius data cleanup. We have one more, which is N. Let's do the sorting again. So N would be fruit. Sort it, do fruit. We have fruit here. It's again in the top end, something that's smaller than 1. We have 2 zeros, we'll take them out, put in the median. That's what happens over here. Let's go back to our error analysis here. So now we have 0, 0, 0, 0. So now we fixed all the errors. We've put in the median for the rest. So now we should have a clean up data sheet. The only thing we haven't fixed yet was the respondents. And let's also deal with that before we move on. So first of all, we need to understand what is going on here in terms of this one. So we know we have one more number. So let's put the numbers back in order so we can work with this one. So I'll sort it up so we can see it in the correct row. So we'll do this again. So we'll sort it. We'll do the sorting based on respondents. So yeah. Based on column A, there we go. All right, so we'll go back and take a look. So now, oh, sorry, we have to look at column B. So let's do this again. Sort column B, respondents. There. All right, so let's do the expected count again. We'll put them up next to each other. All right. And in this case, you can see the difference here. The easy way to do this, well, we can of course do it manually to see when they don't do it. So in this case, we'd say, all right, so here there is a distance. So when is there no distance, we can go up in the data set. And I'm looking at these guys here when I'm scrolling up just to see when the difference starts. So here they're the same. Here they're the same. Here they're not the same, so we're getting closer here. Here they're the same. Here they're the same. Here they start to differ. So it does look like we do not have a 260, right? So if it's just a matter of missing a number, I think we're good, because then we can just treat these ones as names of different respondents instead of a numerical ranked number. So in this case, we do not need to fix it because then we'll just treat this one as a label. And if we don't have 260, it doesn't really matter. The only thing it matters for is the total number of observations, so the n number. And in this case, we found the n number to be, I think it was 663. So we did the count. So 663, even though we have 664 observations. 63 as our n. 664 is the total number. It'll just be a label. All right, so back again, the cleanup data sheet we have put to the right. Go to the top here. So this would be the right one. We do not need to exchange this one. So this one is just a standard number that it's been given. So what we do here is then take this one. And then let's put in the missing data as well, even though they're maybe not cleaned up. So we need to put in the extras over here. And we'll just do a straight copy. We'll do these guys. Straight copy. And put them in here. And then what I'm normally doing is that I'm going to take the full data set, this one, do a copy of that, and then input that in a new sheet. I'll input it as value. And there you have a cleaned up data sheet. So there you have it. That's how you actually clean up the data sheet. And then you have it in a new one here, which is called clean data. So that was step number 3 to do the data cleanup and organization. So now comes the fun part. Now we are going to figure out how to choose and decide the optimal number of clusters. And in order for this one, to do this one, we'll then have to produce an elbow chart. So before we go into that one, let me just refresh your memory in terms of what is an elbow chart and how does that work. So the elbow chart is this chart where we are looking at the distance between different clusters, so the variance between the clusters and the variance inside the cluster. In order to describe this, then it's probably better to look at this one. So here you can see that we have data put up on 2 dimensions, and the yellow dots are the centroids, so the center of the different clusters. In this case, we have then 5 clusters. And then we are looking at, for one number, the distance between the yellow ones. So how big a distance do we have there? And then we're looking at distances within each cluster. So that's the data we're going to be looking for. And then we're going to run a data set with clustering on 2, 1, 2, 3, 4, 5, 6, 7, and 8. We can't cluster with 1, but from 2. And then look at the variance in the distances, so within cluster variance and between cluster variance. And then we'll use that data to determine how many clusters should we probably have. So we actually we do a clustering analysis for all the number of clusters we think is relevant. So that's what you see here. Here we've run clustering analysis with 2 clusters, 3 clusters, 4, 5, 6, and 7. And we've picked out the data that gives us the within class variance and the between class variance. And then we do an ratio between one and the other, and that's the elbow ratio. This elbow ratio is then the one we show in the red graph here, and that is the elbow chart. And then in order to determine the number of clusters, we have to look at where the assumed elbow would be if this was an arm. In this case, it's not super clear where it is, so it could be somewhere around here, 4 or 5, most likely. I don't think it's going to be there, but it's probably going to be 4 or 5. So to determine what that is takes a specific decision, but that's the kind of number we're going to be looking for. So how do you produce this? So let's take a practical perspective on that. You need to run a clustering analysis. You can see the output over here with the data set that you have. And then within the clustering analysis, you have, first of all, the average distance from a centroid, which is the variation in the different clusters, so within the group clusters. And then you have down here the distances between the clusters. So that is between cluster variance. So that's where you get the data from in Minitab. But let's take a look at that. So how do you run this in Minitab in order to get this data? So you can use this data to put into your elbow data chart here. So let's take a look at that. Let's go back to our data set. Here you go. So first of all, we have to take our clean data set, and we'll have to, and it's organized now, so we can bring it into Minitab. So in this case, we'll go from respondents here down to the last point here. There we go. I'll do a simple copy paste. I use an older version of Minitab, so if you have a newer version, it's no problem. It's basically the same operation. Then I input it with a simple copy V, and then I have all my data here. So the next step is then to figure out how to do the clustering analysis. So what we want to do now is then to find the how you do the clustering, so where you do it in Minitab. All right, so first of all, we need to find where we do the K-clustering analysis. And in Minitab, you do that under Stats, Multivariate, and Cluster K-means clustering. So in order to set it up, you have to decide what variable. So we know we're going from milk, chocolate, down to mint. And we'll select that. And then we'll have to run the analysis for the different cluster numbers, and then use that for our chart. So in this case, let's start with, we're using 2. So we'll run that analysis. We'll do that again. We'll run it for 3. Okay. We'll run it for 4. Okay. Let's see if I did it correctly. I do not think I did it correctly. Oh, we do have them, yeah, the same one. Do for 5. Stats, K-means 6. Stats, K-means 7. And stats, K-means 8. All right, so now we have the clustering. All the output data is then on this reporting sheet. So that's where all our data is. So the next step is then, of course, to pick up the data that we need. So let's go back to take a look at what the Excel sheet looks like. All right, so let's see how we take the data and produce the elbow charts. The first thing we're looking for is the within cluster variance. And in this case, we have two clusters, so two clusters. And from the PowerPoint that you saw before, what we're looking for is the average distance from the centroids. Now we need within cluster variance, so average distance from the centroids, we actually have two numbers. So the simple thing to do is just to make an average of those two and input it. However, because you can see that there is a difference in the number of observations per clusters, what we should do to get a good number is do the weighted average. So we'll weight the average distance based on the number of observations in each of the clusters. So what I typically do is I put in a little help chart on the elbow cluster analysis because we're going to do it for a number of different clusters. And my little weighted calculation sheet looks like this. So I set up rows so I can input the number of observations. I set it up so I can calculate the share, and then I can input the average distance from the clusters. So here you can see that I put up 51,612. I calculate the total, you can see here. And then I set up a little formula to calculate this divided by 663. That gives this number. I also put in a control just to make sure that there's no error in the calculations. So that's what my weighted calculations look like. And then the only thing I need to do then is input the average distance from the centroids. In this case, it's 0.908. I take it from the average distance from the centroids. Second one here is 3.748. And then up here, I put in a formula that basically takes this multiplied by this plus this multiplied by this. So a standard weighted average calculation. I just set it up for all of them so I can automate the calculations. So in this sense, I now have a weighted average. So between 1.9 and 3.7, the weighted, when we have the number of observations, the weighted average would be this one. And in order to expand this, let me show you how to do that. We basically expand this to the next one. And then the next one has 3. Has 3. We don't have the numbers yet. Expand this to this one. Then we're looking for the number of observations in 3. Well, let's do 3 as well. So this is 51, 102, and I'm taking it from number of observations over here. And 510. The percentages are calculated correctly here. You can see that. Let me extend this one just to double check we have the right one. So that's 100. I then input the average distance from the centroid, 1.908. 5, 3, 2. And then I now have the within cluster variance up here. Now, the second thing we need to do is to then find the between cluster variance number. Okay, so for the between cluster variance, we have the data for 2 clusters. We have that between clusters here, and this is really simple because we only have one number. So we just basically take that one number and we could put it in here between clusters. However, as we have a number of others to run, I also have a little help sheet where I put in the between cluster variance. So let me show you that. So what I do here is that I grab this one, I dunk it into here, and then up here I do have a formula that calculates the average for all the data that's underneath. So you can see here, it's really simple because that's straight from here. And the only thing we need to do here is then to bring the average in, right? So this is what we have here. So now we have it set up for 2, but let's look at how it goes for 3. So when we go in here, we have distance between the clusters for 3 clusters. And I could put them in manually, but when we have more and more, what I tend to do is I actually just do a copy paste. So, so Control C. I dunk them in over here. I use a function under data in Excel called text to column. I do it with fixed width, so I split them up so I can use them. And then I grab the data from here and put it in. So I need these two. You know, you only need one set of data, so that, and that data, this is what we need. I bring them over. Here, here, delete the rest. And then you can see the average is calculated. And then up here, I just extend this formula. And so forth, right? So you can see that's how it's going to be looking. And that's it. So, so the next one, so if we go for 4, we'll just extend all of these ones, all of these formulas. We will put in the new data. So this one is again 51. I'm taking it from over here. 102, 108, 102. Extend this one to 4. And I input the average distance from the clusters. 7. And the between cluster variances for 4. I'll have a bigger sheet here. Control, copy. Input it here. Data tools, text to columns, fixed width. Yes, yes, yes. Grabbing the data. This one, so I don't have to input it manually. Extend the average. And all of a sudden now we have input the next one. And that's how I do it for the rest, right? So let's do number 5 as well, so you can see it. So I just extend the formulas. From 5, I have these other numbers, number of observations. So we have again 51, 90, 48, 102, 12. And the percentages. There you go. Just control that we have the right amount. Average distances. Um, 1.8. Now you can see here we have a bigger chart with distances between clusters. We'll grab these again. Go down here. Data tools, text to columns, fixed width. Yes, yes, yes. Finish. Grabbing the data. And this one, there we go. Delete what I don't need. Extend the average. And there you have it, right? So this is how you do it. and then you fill it out for the rest. So that's my little cheat sheet in order to produce the elbow chart. So what you see now is that I have completed the input of all the data for between cluster variance and within cluster variance, and done the weighted average calculation. Down here, you can actually see the weighted averages. I also input a simple average in order to see the difference. And in this case, you can see that if you're using a simple average, then it's significantly lower for the lower number of clusters. But when we go up to the higher number of clusters, you can see that simple average and the weighted average, they become very similar. I take the data from this cluster area, I put it into a graph tab. So I basically just have the data copied. You can see the formulas here that comes from the worksheet. So these data are where it's come from, and then I produce the graph based on that data set. So that's what it looks like. So there you have it. This is how you produce a an elbow chart. So the next thing we need to do, you can see here, we've talked about the purpose of targeting, choice of dimension, we've done the data cleanup, and we have produced the elbow chart. We need to use that to decide the optimal number of segments in a cluster. And in order to do so, let's take a look at the data we have. And here you can see the elbow ratio. Data set doesn't necessarily need to be super clear. So what I do when I try to make the determination of the optimal number of segments, first of all, we look at the net gain that we have. So here in this row, you can see show a little calculation of that. If you look at the chart here, what we're looking for is where we do have the elbow, and it's a visual analysis. And for this chart, it seems like the elbow is taking place mainly around the 6 clusters. So when I'm looking at this, this is where it really starts to flatten out. The first time you have some gain here, so there's something going on here. But the normal rule of thumb is that you look at the lowest amount of clusters where it breaks. So we'll probably, based on the visual analysis of the elbow, we'll probably say that it looks like the elbow is around, for this set of data, around 6 clusters. If you look at the net gain here, you can also see that 6 clusters is the last number of clusters we have before we go into its flat, or in this case, a negative area. So this is also an indication of that that's probably where we need to go. So now we've decided the optimal number of segments, so we say 6. Then we're going to do the clustering analysis, the real clustering analysis. We actually run it already, but we'll do it with 6. So we have the right number. So what we do is that we run the k-means clustering with 6 clusters. And this time we make sure that we use the storage function so we can get the membership of the clusters into the sheet. So in order to do so, I usually start with here, cluster membership. That in here. Then I run the cluster analysis, multivariate cluster k-means analysis with 6 clusters. Go into storage. I choose cluster membership as the output storage area, and then I'd simply just run it. And then you can now see the cluster membership here. We now have this data. And then what we do is then we grab this data, do a copy paste, and transfer that into Excel. Here we go. So this is the original sheet, and then we can basically input what cluster they belong to by copy pasting it. Oh, there was one more up here. Up here. There we go. So now we have who is in what cluster. And that is an important element because now we can then separate all respondents up into the different clusters. And I marked the, one corner and the other corner of the area in Excel. So now I mark this one. And then I move up to this one. And then I do the sorting based on cluster membership. Bang. So now I have set up my data of who is in what cluster. And then the next step is then to profile the different clusters or the different segments, and which is then possible to do. So you can see here that what we can profile the different clusters or segments on would be age, gender, and location. All right, so when we need to do the profiling analysis, the first thing we need to do is set up an area where we get our analysis data. And you can see I've set up an area here where I, in the column X, put in what types of so we want to do the cluster profiling. Then we need to set up an area where we outline the data that's needed in order to do the graphical analysis. So what I've done here is put up an area where I do the profiling analysis. You can see here that I've put up the 6 different clusters, so I can profile all the clusters. And then I have an area where I can do my analysis. So let's say what we can do here. Given the data we have, we know we can analyze the profile on age. And in this case, we can just do an average age based on the data for each of the different clusters. I also want to take a look at the gender split. In this one, we first of all have to calculate the number of males, then the total number of genders we have, and then we can do a male and female percentage. I also want to look at the cluster size. So we do have a number of people belonging to a cluster. We want to see how big the clusters are. And then last but not least, in this case, we are looking at location, and we will use city as the identifier for that. So first of all, we have to calculate the number of locations per cluster before we can then do the percentage. So that's what I've set up here to do. So let's take a look at it. Let's do the average age calculation first. I already put in some formulas, so bear with me for a second. Then I will show you the formula. In this case, you can see here that it's a straight forward average. You can see the blue area here that I do an average for everyone that belongs to a cluster, and you can see the cluster membership here. Right, that's where you see that. So this formula I've done for each of the different clusters. So you can see up top here, this is from Q4 to Q54. And you can see the other ones here. So that's what you need to do in order to produce the average. In order to produce the male-female split, what I've done, let me show you my calculations here. What I've done is I've inputted a COUNTIF function. So I count this area, and I count it with the rule of 1. So it counts the number of cells in this area that has a 1. I could also count the ones that were female, but I count the total number. So what I look at here is just a simple count of the total gender numbers where we have a gender. and based on that, and then do the simple calculation. The simple calculation is then male numbers versus total, and this residual would then be the females. So you see that's the residuals. So that's my calculation for the male and female split. Let's do the calculation of the cluster size. Let me show you how I done that. So the cluster size is basically a count of all the cluster memberships all the way down. And then I use the count if. So if the cluster membership is 1, I get the number of members of that cluster. And you can see here, if I go to the second one, the only thing that changes would be the number 2. So it's the same range. Here it's number 3, and so forth. So this is very simple count if function using the cluster membership number as the identifier. Then I also have to count all the respondents. We already knew it, but I want to do just a check. So in this case, I actually calculate the ones where I have the number of clusters, just to double check that it's correct. And then the simple percentage calculation, I'm sure you can do that no problem yourself. So we take the cluster 1 divided by all respondents in order to get this one, and that's the same one for this one. We take this one divided by that, and that gives us the cluster size percentage. It's very simple. Last but not least, we need to do the count of the different cities, and let me show you how I've done that. In this case, I use a count ifs with a plural ifs function, so I can add different ifs together. So the first one I look at is to identify how many of the, and I use the same, I use the total list here. I don't separate it up. So that's why I use the ifs here. So first of all, identify the ones that are belonging to New York, and then I test it against which ones are in cluster 1. So New York and cluster 1. That's what that formula stands for. So count if function, right? And that gives me the number here. If you see, if we go down to this one, note that what is changing is x13 to x14. So x13 to x14. And that is the city name. So that's the only thing that changes. So if you look at the formula up here, look at the x's, that's the only thing that changes as we go down. So you can see here, 1, 14, 15, 16, 17, 18. When we go across here, you can see what's changing is this number, 3, 4, 5, 6. So that's the formula that I copied in to all of these cells. In order to make sure that we have correct numbers, I did a little control function. So I actually totaled out the location totals, and I looked at if there were any difference here between the total, and in this case there is not. So in terms of the locations, let me just share with you the formula that I used in order to count up how many we have in cluster 1 of New York. I use a count ifs formula, so there are 2 if formulas within one. I basically mark out the whole area, so I don't only mark out the ones in the segment, but I mark out everything, and you can see it here. So I mark out all the cities, and I mark out all the cluster memberships, and the only thing is then that I separate out what city we are looking at, which is the X column, and then I'm looking at what cluster membership we are talking about. So those are the only two. So the X13 here goes to change, and the ones goes to change to 2, for instance. So, so let's take a look at the formula, how it's spread out. So look at the formula on top here. Follow with this one. So when I go down, so city to city, the X's changes for X15, X16 as X17. When I go right, the last number, so the number here changes. this case, it's 1, 2, 3, and 4. So that's how I produce this. So normally what I do here is I grab this one, I extend this one out, and then I get the different numbers. And this one I extend down, and then I can extend it to all the different cities. So the next part is then just to make a percentage calculation. For that, we need a total, of course. So you can see the total here that's been extended all the way. And then it's just a very simple a ratio calculation or percentage calculation. And that's what you see down here. You see the formula here. It's very simple. The only thing we keep stable would be the location. So that the 20, the location totals here, right? So you can see when you go across here, that you change the totals, and third one here, so you see that goes across. And then when we take it down, you can see the formula goes with the y's here. So that's how you do the percentage. So there you have it. That is the data foundation for the graphs. So in order to do the graphical analysis, what I typically do, I create a graph data sheet, and then I bring over the data that is needed to produce the graph, so I have them separately. I've started a graphical data sheet here. You can see it here. So I think we want to show the age, the average age for the different clusters. So that's graph data for one. We want to show the male and female split for the different clusters. That would be graph number 2. We want to show the size of the different clusters. That would be for graph number 3. And then we can do an analysis, a graphical analysis of the shares of locations, and that is for graph number 4. So what I typically do when I produce graphs is that I mark out what I need. In Excel, we can use recommended graphs or all charts, and then you can actually see, the different types of graphs, what it might look like for your own graphs. So in this case, I like the color one, so we'll do this one. I'll say okay with that one. So I have the first graph. I can then, mingle with it. So for instance, I'd like to probably have, let's see if we can get the whole area here. I'd like to have data legends on it so I can see it. So then I play around with the legends in order to get that. So data labels here. Let's do outside end. There we go. Then we can see the average grades. You can also look at titles. So for the titles for everything. So here you can put it in manually if you want, or you can actually link it up. So in this case, I actually want to put in my own title. So I just mark it out and say average age. Clusters. And then I have my chart. For the second one, let's do the same thing here. We go in and insert a graph, do the recommended charts. Then the question becomes, how would we like to see this one? In this one, I think the stacked one is probably a good one, so we can see male versus female. So we'll do that kind of chart. And we'll do a chart title. What do we want to call this? We call this gender. Do that one. And then we have the second graph here. Use that one. We have a size. We'll do the same thing with that. Insert recommended charts. So how do we want to look at the sizes? Let's do a simple chart here. And in this case, we want the legends as well. Outside end. This one out. Cluster size and percentage, that's perfect. So now this one, it picked actually this one up, so it linked it to it, so which is perfect. And then the last one is the more difficult one, and that is to do the analysis of the location shares. All right, so let's take a look at what we can do here. So insert recommended graphs. So we need to figure out how we would like to analyze it. I think this one, stack one, looks pretty good. So let's look at that. Do not think we want to look at per city percentages because that's the wrong way. So that's percentages like this for New York, and you can't really compare these percentages. So what we do here is then we actually switch rows and columns. So you can see you can now get per cluster the data. So you can look at each clusters, and then you can look by the size of the different percentages. You can see the differences between the different clusters. So let's use this one. We probably want to format the axis here. The maximum will be 1. So we can see it. 1, and let's put the chart title in. We would we'll put in, what should we call them, cluster. Location. So now we have produced 4 different graphs for the data. So we now have profiling data to start our analysis. And then what is really simple here is then to bring over the charts into a PowerPoint format and then use that in order to produce the analysis. So there you have it. We have now gone through the different steps of the targeting analysis. You can see we've chosen the purpose. We chose the dimensions for the flavor. Remember, we're looking at potentials for producing new products. We cleaned up the data sets. We analyzed data, produced the elbow chart, decided that there were 6 segments we would look at. We clustered them. We identified who belongs to what segment, and then we have now profiled each of these segments in order to produce analysis of how these stack up against each other. And there's a number of different ways we can profile it. There's also other graphs we can show for the different profiles for different dimensions, but this is just one little example of what a profiling analysis would look like for each of these clusters. So thanks for listening. Hopefully this has been helpful in order to understand how you, through statistical analysis, can develop a targeting analysis for a different or specific purpose.